All right, taking a look here, some more multiple choice. The graphs of the functions f and g are shown above. The value of the limit as x goes to 1 of f of g of x is. So I think a couple ways to think about this problem. One, when we're talking about limits, we don't care about points at all. They are trying to throw us off with that point right there. So let's ignore it. So the limit as x goes to 1 of g of x clearly is, from the left and from the right, 2. So that is 2. You would answer that with 2. So then we just look at the limit as x goes to 1 of f of x at 2. So now we go here. So now I'm putting a 2 in here, and that value is 3. In my mind, that's how you got to think about it. Any questions? All right, we've got another limit problem here. The limit as x goes to 0 of this function. What do you think? If I put a 0 in, I get 0 minus 0 over 0 plus 0. So it starts as a 0 over 0, which means we got to go further. L'Hopital's rule allows us to take the derivative and check the slopes. So let's try that. 7x. The derivative is just the 7. The derivative of sine is the cosine over derivative of 2x plus 3 cosine 3x. So now let's try putting that 0 in. 7 minus the cosine of 0 would be 6. That's going to be 0 plus 3 times the cosine of 3 times 0, which is 0. The cosine of 0 is 1. So now we do get a value, 6 over 3, which is 2. All right, what are we assessing on here in 3? If f of x equals the sine of the natural log of 2x, then the derivative is, what are we assessing on? I think we're assessing on the double chain. So we start all the way outside. The derivative of sine is just cosine, and nothing gets touched inside, times the derivative of the inside. The derivative of the natural log of 2x is 1 over 2x times its derivative of 2. There we go. The 'two's are going to go away. So I'm going to be left with the cosine of the natural log of 2x over x. There it is. All right. The graphs labeled 1, 2, and 3 above. One of the graphs is f, one is the graph of f prime, and one is the graph of the second derivative. Which of the following correctly identifies these 3 graphs? I like this graph interpretation question. So let's start out with looking at where things are 0, or where their slope should be 0. This one has a slope of 0 at, let's say, 2, maybe right before 2. Neither one of these have zeros at that point. So I would say neither one of these are the derivatives of it. And that right there should actually be a big hint. But let's continue looking. Right there, that one has a slope of 0 right there. This one has a 0 there, meaning it is probably the derivative of this one. Let's check if the next one's right too. 0 right there, 0 right there. So this is definitely this one here is the derivative of this one here. Then let's check this one. It has a slope of 0 here. Let's go relate that to the first one. It has a 0 right there, meaning this is the derivative of this. So here's the function, here's the derivative, here's the second derivative. Which one is that? There it is. That's how I would explain that problem. We do have a local linearization question here. The local linear approximation to the function g at 1/2 is y equals 4x plus 1. What is the value of g of 1/2 plus g prime of 1/2? So let's talk about what this means. If we have a local linear approximation given, that means we're given the tangent line. So that is the tangent line. So we're tangent at the point 1/2, and that's our graph. So what does that mean? So the slope is 4. What is slope? Slope is g prime. So g prime of 1/2 is 4. There we go. Then, for it to be the local linearization and the tangent line, the tangent point also has to be when I put in the 1/2. So y of 1/2 is 3. So g of 1/2 is 3, g prime of 1/2 is 4. I'd say that one's on the more difficult side.